Right, I know we're about ready for the class 10. I was speaking to some of my students here at Grand Canyon, and they all have the same look on their face. So I'm pretty sure you're all feeling the same way. We- We've had enough weeks of this, but that's all right. Just a couple more and you'll be done. So um, before I get started, um, just a quick note, the actual last day of class for the fall semester is Friday, December 19th. So, and I'll talk about the final project and the final exam at the end of this lecture. So you're all made it this far. You can make it to the end. So keep at it. All right. That being said, welcome to week number 14. And in this module, we're going to cover privileges and regular expressions. The privileges and roles, I will tell you right off the bat, you'll be required to build the queries. You cannot run them in SQL Developer. With this instance that we have for students, you can't change the privileges, but you will be required to build the queries. So I will remind you of that when we get to the assignment. And yes, we have practice queries and all that. Once again, you're not allowed to change roles and privileges in the developer. I mean, you usually don't have that higher level of administration unless you're a database administrator. But just in case, this is a part of the Oracle Academy lesson. So let's get right into it. So 14, topic 1, controlling user access. Objectives compare the difference between object privileges and system privileges. Yeah. So I will reiterate, this is mostly theoretic and good information. And if you happen to have the chance to be a database administrator creating users, yes, this comes in handy. Construct the 2 commands required to enable the user to access a database. Construct and execute a grant on or to statement to assign privileges to objects in your schema, to other users, and or the public. Query the data dictionary. Now you can do that to confirm privileges or even just view privileges. Right now, that'll be your best bet as far as, and generally the way it's kind of a learning environment. So that's why it's set up that way. All right, so this purposes talks about if you share a computer, whether it's school or work or home, you do have to, and it's security as well. So you do have to possess the ability to understand who has access to what, who has privileges to do what. So basically the premise is that wouldn't it be nice to control the privileges? And for databases, yes. And as a former DBA, this was a big deal because you want, on the security side, you want to adopt and understand the privileges or the process or the right of least privilege. And so there's your cybersecurity lesson for today. All right, so controlling user access is the first thing we're going to talk about. Most environments are multi-user environment. Even if you set up a database at home, you probably have other users. So at Oracle, you can do the following. You can control access to the database. You give access to specific objects. Remember, database objects are like tables or sequences or constraints. Those are objects in your Oracle database, and confirm and basically view privileges within the Oracle Data Dictionary, and even create synonyms for database objects. And we already did that. That's actually an add-on for this section that we already covered. Yes, we went synonyms. I should take that off of there. I did change that. But anyway, we're not going to go through synonyms again, so don't worry about that. All right, so database security, just like other digitization and cybersecurity, is classified in 2 major categories, and that's system security and data security. System security covers, and just to let you know, you will see, security from this premise on the final, just maybe a question or two. System security covers access to the use of the database at the system level. So such as creating, which is why you will not have access to modify or even create users and usernames and all that. That's a level above. So I'm just giving you the aspects of system security. Things like allocating disk space and granting system level privileges. And this is usually a system admin. This is actually usually a person that's even above, in some regards, depending on the size of your company, above the database administrator. So there's more than 100 distinct system privileges. Just know that it's a large number, and generally there's that special person that has those admin privileges can only modify those. All right, data security or database security, and this is also known as object security, relates to objects, and objects in your database are we talked about objects, tables, sequences, synonyms, or not synonyms, but what other objects do we have? Certain functions, etc. So you can actually control the privileges to those particular items. So, and that does include the ability to execute DML. Remember DML, the update, insert, and delete. You can change the privileges. Well, if you're the DBA on those aspects of your database. Woohoo, right? So basically, a definition of privileges. Privileges are the right to execute particular SQL statements. So, and a DBA is usually the highest or the higher level user with the ability. So you're technically not DBAs, which just to explain a little bit to update this information, we all use an instance of essentially the same database environment in Oracle, even though you have your own access, it's still an instance, and you could possibly, if you're curious enough, create a problem for other users. So that's why you do not have the privileges to modify privileges. So even object privileges. So as I go through these, take mental notes, take physical notes, just make a note of it. Just keep in mind what you can and cannot do. And I'll be going through these pretty rapidly. It's only because hopefully you can reference them in the module and in the lecture when I post it. All right, so a schema is a collection of objects, that, such as tables, views, and sequences. Those are objects. Those are objects that we know. So the schema is owned by the database user. You are the database user. And basically, you're the user at the level where you can access all the objects. But so in this course, the schema name is a combination of it really isn't. We don't have specific schemas. So this particular slide, normally we would set you up with a particular, modifiable database schema, but we don't. So that slide is not really applicable anymore, and I'll have to make a note of that. So essentially, I'm going to summarize system security because we did change this quite a bit. You, once again, do not have the privilege to create users, drop users. You can drop any table with conditions, but you can't back up but you can select and create. So there's some modified privileges as far as system. And you get a chance if you like to test some of those, but as far as the user and the way the hierarchy is formed in Oracle now, it's a lot different than it was 15, 20 years ago anyway. So once again, I'm going to highlight these queries, but make a note of them theoretically, but you will not, once again, be able to run them in SQL Developer. So the create a user, the syntax is create user, the username, and then identified by password. And there you have the syntax for that. Make a note of that. And this is the new slide. So we will not be able to run the create users or any other queries. We will get an error, insufficient privileges. So if you're curious, you can run that. You will mostly run into that error that says, oh, we want you to learn about privileges, but you don't have the high enough privileges to modify any privileges. So once again, be aware of that. And that's why I created this slide, because if you try running these test queries, as far as users, specifically with users, some of the object or database security, you may be able to run. I would just be aware that will be an obstacle that you'll run into. All right, so to alter users, you can alter users with this syntax, alter user, and then remember the identified by is basically the password. And system privileges, there's so many different ways that you can modify system privileges, which once again, you make a note of it, make a note of all the slides, create session, create table, create sequence, create view. Now we can create a table. As a matter of fact, you will need to create a table. We do. So I will repeat again, you just have modified privileges within your database schema. You can create views. You can actually perform all of these actions, although you will not learn about procedures in this class or packages or anything like that. If you go on to take the PL SQL in the transaction class, you will have excuse me. Just checking the attendance right quick. I see a few more individuals have joined us. Yeah. All right, continuing. And I'll repeat myself again. You do have most of the object privilege or data privileges as far as object security. And this is the level that covers access use of any of the objects, tables, sequences. So here's kind of a table that highlights the incredible privileges that you have now. Alter, delete, execute, index, insert references, select, update, and then the objects table view sequence. Don't worry about procedures. We're not getting into that yet, but you do have select and alter for sequences and views and tables. This is essentially an illustration of the object security privileges that you have as a user. All right, so it is important to note the following, these 4 points regarding object privileges. The only privileges that apply to sequence are select and alter. Remember, a sequence uses alter to change the increment, change all of these particular items, max value, cache, no cache, all of that is alter. So you do have the privilege to do that. Start with, and alter cannot be changed using alter. And we talked about that before. You actually have to create a new sequence. You can grant update references and insert privileges on individual columns in a table. So you do have as far as your privileges on the table as an object, there's no limitations there. So here's an example, grant update. So you're granting that privileges to Keen. Can you? Okay, let me rephrase this. Yes, you can view the privileges, but you can't alter the now we'd have to test that. So if I know you have you have exercises where you can check and test the privileges on certain objects. Some of them you can run, some of them you cannot. You can't grant select on individual columns. So you can do a lot with privileges. For example, privileges granted on a synonym, what those is converted to privilege on the basis of the table, basically because a synonym is just a kind of a renaming or alternate name. So this is just saying the privileges on the table is transferred to the synonym if that's the object that the synonym is associated with, and that's common sense. All right. You are the owners of the tables in your little schema. So you can grant some privileges to objects, and I can't overstate that. So, and I do want to say, if you run across any errors, just if there's an assignment, I think I took those up, but if there's an assignment that's requesting that you grant privileges, just run the query, and if you're brave enough to run it, and you can always refresh your schema. Just go ahead and run and just take a screenshot of the error message that is performed, and the only error message you receive is insufficient privileges. So please don't worry about that. So this talks about users and specific users. Remember, you cannot alter any user privileges. Even using the public keyword, you can't change the privileges to the way that they're set up on your schema. And you're probably saying, well, why are we even going through this? You may run into this even as an analyst. Some DBA may ask you to change privileges in a department or whatever. So it is possible that you'll need to do this. All right, if you attempt to perform an unauthorized action, such as delete a row in a table, the error messages will primarily give you a pretty good idea what the problem is. If you receive an error message, table or view does not exist, or you've done either of the following. You put in the wrong table name, or you attempt to perform an action or operation that you do not have privileges to do so. And that slide is not applicable anymore. You can view privileges in your schema now just by using the data dictionary. And here's a list of the data dictionary tables that you can view: the system privileges, the object privileges, and so on. It's a good idea to go through these just to see what's in there, and you'll see your little user ID and what you have privileges to, and you may even be able to ascertain some of the limitations that you have on the privileges. And I think that's primarily why we expose you all to this particular part of privileges within your Oracle. So here are our keywords for object and system privileges. And this is all about security. This is your security lesson. All right. So we're gonna expand a little bit on the object privileges. This one you may be able to impact. I think you can impact some of it. We're going to talk about roles as they are associated with privileges. So one of our objectives is explain what a role is and what its advantage are. So all of this is associated with access and managing access. Construct a statement to create a role and grant privileges. Construct the grant onto with grant option. Some of these, yes, let's just go through these. Once again, there's some limitations here. I do want you to understand and distinguish between privileges and roles because there's a little bit of difference. And then explain briefly the purpose of a database link. Database links aren't used that much anymore. You probably can guess why. Most of our databases aren't linked across some infrastructure. It's usually a cloud or on-premise, and the resources are so robust now. You're not necessarily linking to different schemas. Most schemas, if you're merging, they're all one instance. So anyway, the technology has changed quite a bit, but the Oracle Academy wants you to always learn the kind of the foundation. And the whole idea of privileges, we talked about that before, but roles, and not dinner rolls, but roles, is the name of a group of related privileges. So remember that actually is a test question. So this method makes it easier to revoke or maintain privileges. A user can have access to several roles, and several users can be assigned to the same role. Oh, is this getting complicated or what? No, it's not really that bad. Just think about it. You have so many department heads, so many, you have a host or hostess in a restaurant and so many waiters and waitresses. So well, anyway, that's kind of a rough metaphor or an example. And roles are typically created for specific database applications. So roles are very similar to privileges. Just remember how they are associated. So you can create a role and call it manager or supervisor. Create table, create view to that role. So anyone that's assigned to that role will have those privileges. And then you can grant that particular role to a user. So that's usually the association. Create the role, grant privileges to the role, then assign users to the role. Here's the syntax to create a role. You saw that. After the role is created, the DBA can grant, and usually this is all DBA work in the very beginning. The DBA is setting up roles and privileges right from the start. And just as I showed you before, this is kind of a repeat slide. If users have multiple roles granted to them, they receive all of the privileges. So this is another way to organize, access and manage access. So some characteristics of roles. Roles are named groups of related privileges. Said that before. They can be granted to users. They simplify the process of granting and revoking privileges because you can grant the whole role and it changes all of the users in that role. And usually 99.99% of the time, these are created by and managed by the DBA. Here's essentially syntax to granting object privileges. We saw this before. So you see the syntax here, grant the name of the object, and you can have the name of the object, object privilege, the columnist on the object name, to, and then the user or role or the public. Now, when you use public, you're basically granting that to anyone that has access to that schema. Okay. All right. All right, to grant privileges on an object, the object must be in your own schema, which they are. You must have been granted the privilege to use the with grant option. So it's just saying you have the option, or you have the privilege to grant privileges. They can be confusing. So here's kind of a hierarchy example. Grant select on clients to public. So everyone that can, so basically this is saying anyone that has access to the schema can select on this client's table. And then we can draw it on and say grant update. So only Jennifer Cho can run DMLs, and then basically we're assigning Scott King to the clients. Basically, he would be more of a higher level. So if you can walk through this and basically understand how we're granting privileges and setting roles, then that is essentially a good way to understand the security around granting privileges and setting roles, or setting roles and granting privileges and assigning users, etc., etc. Now, there is a command with grant option, and basically at a high level, this gives you a way to set the opportunity, or set the grantor, or how do I say this? So you either grant them the option to change any of these objects or revoke. So you would use that option. And here's an example. So grant select insert on clients, that's an object, to Scott King with grant option. So he can not only select and insert, he can change you grant him the privileges to change their own privileges. Now, is that done often? No. You rarely will see any of this performed on a regular schema, because now you're losing a little bit of control. And yes, the public keyword is just that. When you set the public keyword, you're opening it up to anyone that has access to the schema. And yes, the two the position in the syntax is to public, and that should kind of make sense. The delete, I guess, object has special privileges, and that's usually a system privileges, which means that delete is always protected because you don't want to inadvertently delete an object. So all this slide is telling you that essentially it's even more than the constraint with delete, because there's always a way to check to see if you really want to delete an object, et cetera, et cetera. As I said before, you can use the keyword revoke to revoke privileges, and the syntax for it is revoke and the privilege to all on a certain object. So you can see you can delineate this quite well in any way. Now, if you use the cascade constraints, this means, and we've seen this before, any association, any relationship, you're revoking all the cascading, objects that are associated with whatever the primary object here. So now you're revoking all privileges to anything that's as far as the referential integrity, which means the primary key, foreign key, the tables that are associated, you're revoking options with that cascading constraint command. That should kind of make sense. So here's an example. We're going to revoke select and insert privileges to Scott King now, after we granted them. And if the user is granted a privilege with grant option, the user can also grant the privilege using the with grant option clause. So it's very confusing. You go round and round and round, and this is why most DBAs won't do this. Most DBAs will not. I will guarantee you most DBAs will not allow any type of granting options to anything as far as privileges, users, or anything, because it makes a kind of a mess. If the owner revokes a privilege from a user who granted privileges to, here's another, it just goes round and round. So you need to take control of that. And here's kind of a pictorial example of the whole cascading. So you see here that grants that basically, if a user A grants select privileges on table user B, including the with grant option clause, user B can grant it to user C. So you see that down the line, if you give them with grant options, they can open up the whole network of computers that have access to that database. I will once again say this is normally not allowed because most DBAs will not want to deal with the kind of hierarchical or occurring or recurring access. So generally, it always starts least privileges, the concept of least privileges. You're going to revoke everything and only have users access the systems or database objects that they need. The keyword private is another way to protect things like synonyms, because you have to be very careful. Someone could have a synonym for their own particular use. I would sum this up by saying this particular session, if you just happen, if you happen to have the opportunity to administrate a database schema, yes, I would guarantee you probably say, well, I'm certainly not going to grant many privileges or set any roles. There'll be administrators and users, done. And you limit, which is essentially the way you all are set up in the database. You're all users, so you have certain privileges, but you're not administrators. It seems like you are, but you're not. So that's just a point of information. All right. Whoops. All right, let me briefly talk about database links. I will tell you that they're really not used that much anymore. Even some of the legacy systems aren't around where you need to have a database link. It's essentially a pointer that goes one way. We only give you access to go one way and not, this is a way to protect exfiltration and things like that. But Oracle thinks that this is prevalent. And basically, and this is because, when the internet was, and we're not using Application Express, this is basically 10-year-old technology. You could access other schemas that are represented mostly like web-based. Remember, this is all web-based. This is all designed before cloud. Most of the cloud technologies, which is what you're using now with your Oracle SQL developer. And you do essentially have a link to an instance in the cloud. And so this is kind of an abbreviated way to look at database links. And see the picture here. Basically, if you're accessing a table, you're almost looking at kind of a remote desktop type of association to the data. That's what a link is. So you can select and view data, but you can't run any DML or anything like that. And typically it's the database administrator, once again, the DBA, that allows, maybe they'll build a view or something. This is the best way to control data if you're using database links. And this is just a kind of an example. If you had access to create a link, and this is a synonym that's created by a link, and it's just saying I'm creating this synonym just to view this table that's maybe a couple of hops away, your network terminology. All right, so once again, point of information mostly. This is all primarily used by a database administrator, granting privileges, setting up roles, but you need to know that and what a public and a private synonym is. Remember, a public is always something that can be accessed by anyone who can access that schema. All right, shifting gears here a little bit, we're going to talk about something that might confuse you, or I don't know, it may make sense, but it's called regular expressions. This is going into more of the coding days and the cryptic understanding how to abbreviate processes. But we're going to talk about regular expressions. You won't hear that too much anymore. When I first started, yes, I mean, regular expressions saved us in many ways, because we were able to put things together, not have to worry about anything particular. It's kind of like a search and match scenario. And so our objectives, I'm going to describe regular expression, use regular expressions to search, match, and replace strings. This was our first iteration of creating a representation of passwords and protected info, construct and execute regular expressions, and check constraints. The check constraint using regular expression, you probably will be familiar with as far as the functionality, because this was the first way that email addresses were checked. All right. So sometimes you have to find or replace a particular piece of text, especially if you're trying to mask it. You already know how to perform simple like, yeah. Regular expressions will go beyond the like. Sometimes you might need to look for very complex text, and there's other ways to do that, even in a database. But regular expressions is the process of basically finding and replacing if needed. Oracle's implementation is an extension of the POSIX, and this is old school. POSIX is back in the Unix days, portable operating systems for Unix. Basically, it was an abbreviated thing created by the IEEE, back in us old engineers trying to figure out how to make items more accessible in a manner of speaking. So what is a regular expression? Or the use of a regular expression is based on the use of meta characters. Meta characters are special characters that have special meaning, such as a wildcard character, a repeating character, and no. So if you think about this can be useful. I mean, it saved a lot of time when it was first introduced. You can use several predefined meta character symbols and pattern matching, and I'll show you this in a minute. The next slide, as a matter of fact, is a kind of a list of the meta characters. So you have the dot, the question mark, the star, the plus, the open close parentheses, the backward slash, the pipe, the up arrow, or the hat, $, and so you can read here what these meta characters represent or described by, matches any character, and the dot, except for null. Null is not anything, remember. Matches 0 or 1 occurrence is a question mark. Matches 0 or more occurrences, the star. The wildcard matches 1 or more occurrences, the plus. Yeah, so these are your kind of your meta characters that you would use in a regular expression. Now, this is probably, well, the usefulness of regular expressions. Well, once we get into the examples, hopefully it'll make a little more sense. But let me try and distill any angst thus far. So a simple regular expression is very similar to wildcard searches. So if we take a look at an example, let's use the dot operator to look for the letter A, followed by any one character, followed by the letter C. So as a regular expression, this would be done as A dot C within the single quotes there. The same expression as a standard SQL wildcard search would be where column like A, remember that underscore C, that would be your regular wildcard for like. So we're kind of, are we making it easier? Maybe a little bit. So here's a little bit of a challenge for you using regular expressions. Which one of these, 1 through 8, which one would we return if we're looking for this, searching for A, followed by any character, and then C? Which one, 1 through 8? What do you think? Who'd like to answer that? A, any character, C. If we're all still awake. I know I put you all to sleep with this lesson. It's the last lecture. Yay. Next week is not a lecture week. So I'm not seeing any responses. The chat is dead. All right, so if we look at this, it's going to be 2, right? Not 1 because it's uppercase, 2, not 3, 4, yes, 5, yes, 6, no, 7, no, 8. How many of you say 8? Who's going to say 8? Well, you would be wrong. So, because it's looking for a single character. So the other examples fail because they don't have the correct number of, and yes, it is case sensitive. Please remember that. SQL is always case sensitive when it comes to text. So yes, it's 2, 4, and 5 only. So Oracle does provide a set of functions that you can use to search and manipulate strings using regular expressions. So you can use these functions on any data type that holds characters, data such as char, club, a regular data or string types. A regular expression must be enclosed in single quotes. So here's some functions. So we have regx like, regx replace. So like is similar to like, but performs with regular expressions. The regx replace searches for regular expression patterns and replaces it with a replacement string. You'll see that in a minute or two. Regx in instr and basically search for a given string for a regular expression pattern, returns a position where the match is found. So in string. And regx substring, as before, searches for a regular expression pattern within a given string, returns the match substring. And then reg expression count returns the number of times a regular expression appears in a string. We specify the string and the pattern. You can also specify the start position and matching position, for example, C for case sensitive. Okay, so do you need to memorize any of that? No. So here's an example. So assume we were asked to list all employees with the first name of Stephen or Stephen. And this does come up quite a bit because the spelling. And of course, you can do this. Remember, you can do this several ways, but if you want to use regular expression, you use a regx like. And as you see here within the single quotes, we have the little up, I guess that's superscript, upward facing arrow, whatever you want to call it. So it's saying that basically uppercase S, TE are the start of the string, and then V or PH, and then EN, and then end of the string. So to read through this, the little, what do we call that, caret or hat, specifies the starter string that's being searched to start the $ ZN, uppercase S followed by lowercase t followed by lowercase e. It starts with the parentheses. Basically, it's looking for either a V, lowercase v, or, which is your pipe, lowercase p, lowercase h, finishes the group of choices, lowercase e, lowercase n, and then the $ is into the string. So if you ran that query, yeah, I don't think I ran that one, but you would find anyone that has the first name or selecting first name, last name, where the first name is Stephen. And I think the only one that would return would be Stephen King. So I didn't put the result there. So sorry about that. That would be Stephen King. I don't think we have a Stephen in our database, but you can check. You can also use the regular expression function to replace one string pattern with another. So for example, for an H, uppercase H followed by any vowel, and replaces them with 2 stars. So start of the string, uppercase H, any vowel, A, E, I, O, U, replace it with 2 stars. And so you see here, if we have an uppercase H in the Dahan, the uppercase H first. So H, and any vowel from the, let me make sure it's the last name. Last name, Dahan. Why did Dahan not change? Oh, it's not the start of the string. That's why Dahan did not change, because that's in the middle of the string. All right, Diana, you have your hand up.
Yeah, I was wondering, why is there not a $ at the end of after the parentheses after you?
There should be. Well,
Oh.
that's not the end of the string. We're just looking at the start. So we're just looking at the start of the string. We're just looking for an H and followed by any of the vowels.
Okay, so you put the caret and the $ if you are searching the entire string.
Yes, you would put the $ after. We're just replacing the H and any vowel with the double star. And it's
Okay.
only at the start of the string, which is why you get Hartstein, Hernandez, Higgins, and Hunold.
Okay, thanks.
Yeah, you're welcome. Good question. So this is a regex replace, and it's a good way to display, you don't want to display certain names or certain parts of private data or private data, you can do something like that. Any other questions about this regex replace? This used to be a big thing. It's not so much anymore. There's programming methods and other ways to do this without running regular expressions, but yeah. All right, there's a regular expression count. And basically, if you have a pattern, you can count how many times that occurs in a string. And the syntax for that's the country name, regular expression count. And the country name column, we're going to count how many times the A, B occurs, A and B together, lowercase, in that order. So in Saudi Arabia once, and Zimbabwe once, and Arab Republic of Egypt once, and you see that that's all true. All right. Gabonese Republic, yep, it's in there once. Is that useful? Possibly. All right. So basically, it's saying if it's more than, we're using this where clause, if it's more than 0, we're going to count of AB, fun. this is probably the most prominent or persistent use of regular expressions, as to develop it into a check constraint. And yes, this one, I've used this initially many times when I had building a relational database for email. So you want to ensure that no email addresses without an @ sign and even a dot will be captured in a table. So if someone makes a mistake entering it in, you wanted to create a kind of a warning that email. So usually a constraint will not produce an error, but so we want to alter that employees table. We're going to add a constraint. It's a check constraint, regular expression like email, and it should. This is just saying it should always have an @ symbol in there, right? This will ensure that the @ sign is there. So and that's probably the most prominent use. As a matter of fact, if you want to expand that, you need to make sure it's an @ and it has a dot, and you can add the domains in there, edu or org or whatever. You can make sure that email follows your criteria as far as a check constraint. So you can see that can be pretty useful. So you can add all of these constraints so that basically the data is not accepted unless it follows those particular requirements. So it needs one or more character. You have this little plus here, the @ symbol, and then the dot where the backslash is an escape character. So that's an escape character. Basically, it has to have an @ sign, a dot, and it has to be more than. And you can create some specifics in that, add domains in there, or edu or .com or .org. So you see, you can do a lot with regular expressions as far as check constraints. Matter of fact, this is probably used now in a relational database, this particular association with check constraints. All right, that's regular expressions, meta characters, sub expressions, and I should add check constraints in there as well because they are used quite often. All right, one last. Yeah, I think we don't really have a lecture next week, but database transactions. Now, with this basic SQL course, our transactions are associated with the system that's running these transactions for you, and you can utilize them for certain. You don't have. There's an auto commit when you run a query, and there's always a rollback necessary. Unless you want to set a save point, and we'll talk about that. But we're going to look at these three advantages well, there are three advantages of these transactions, these statements that are transaction related. Explain why it's essential from a business perspective to control. Well, at this level, you're not really controlling the function of controlling the flow of transaction processing, because generally you're running one or two queries without basically no concern about other types of processes within your queries, which is fine. All right, so we have to highlight the whole idea of transactions. So what if a bank had no systematic process? And we all know that we're all embedded and deeply embedded in processing transactions now. So how would you know if a deposit was credited to your account before you needed to withdraw money, blah, blah, blah. Fortunately, banks control transaction processes to ensure data consistency, and that's been around forever. So in this lesson, we are going to learn about how things connect to each other. We're going to look at three specific statements that are like basic transactions. All right, so what is a transaction? This is a fundamental concept in all database. It is, and it allows you to make changes to data and then decide whether to save or discard the work. Typical processes in most technological association. Database transactions bundle multiple steps into one logical unit of work. Yeah, it's really interesting how this is performed now without any. And there's no merge. There's no no kind of, I would say, probably no negative in putting things together as is associated with a transaction. But anyway, I'm just reflecting here. So DML statements which constitute one consistent change to the data, that's a transaction. A DML statement includes, insert all your DML, DDL, your create, alter, and DCL is that grant and revoke, which, yeah, we're not performing much of that. So if we get back to our banking example, a bank database contains balances for various customer accounts, as well as total deposits for other branches. Yeah, that's a key. So it's all tied into one big database. We all know that. Or one instance that can be accessible, whether it's a view or whatever. So suppose a customer wants to withdraw and transfer money from his account and deposit it into another customer's account at a different branch. Well, we can do that. There are several steps. I'm not going to highlight all the particular steps, but we've all been to the bank. We can check, and because there's several branches, depending, even some of the smaller banks have several branches. So transactions are controlled using the following statements. Commit represents, and we have auto commit, the point in time where the user has made all the changes he wants to have logically grouped together. Because no mistakes have been made, the user is ready to save the work. So when the commit statement is issued, the current transaction ends, making all pending changes permanent. Now, rollback enables the user to discard changes made to the database. And then essentially, when the rollback statement is issued, all pending changes are discarded and it essentially rolls back to before the changes were made. Transactions are controlled using the following statements. You have a save point, and you can probably figure out what that is. This just creates that place in the transaction where let's save a spot here. So if you decide to roll back, then that's another way you can roll back to that particular save point. And this is basic programming as well. And if you made an error, you want to essentially, and we all know that, it's not really this rudimentary anymore as far as even the database world. I mean, there's an Oracle and SQL developer, there's auto save backs, and you really don't need to create your own manual unless you need to, but let's say we want to. So in this example, user has issued an update statement and immediately creates a save point. So update department set manager ID from 101, we're department 60, and then you're creating a save point 1. You actually type that in and run it. So when you run that, you get this row updated, and then you get this save point created. And you can name it whatever. Usually it's very simple, save point 1, or you can name it to whatever, save point before update or something. And so if you need to roll back to the save point, you just roll back to that save point. And as I said, you run that. You can run a commit, but in developer, the commits are auto. All you do is verify the commit runs. So if you want to see the commit completed result, but that's what it would look like. Okay. So you may want to ask, when does the transaction start or end? That was a very interesting question. So it starts with whatever your DML, and it ends it ends after you run in developer, but you can do a commit, then it ends. And if you you do commit, then unless you have a save point, then you can't roll back. It depends. You definitely want to roll back. That's why you don't want to do a final commit. We'll call it that. You basically only want to hit commit if you're sure that everything is correct. That's the difference between essentially the way the Oracle developer works now as opposed to the way it worked 10 years ago. And I hope that makes sense. As it's stated here, there is an implicit commit, and we call it a soft commit. And that's always running, and you can always roll back as long as you created a save point. There's not an implicit save point. I know this is not in my lecture, but if you're that nervous about running, you can always roll back, and it'll roll back actually before the last query was ran. And I know that's a lot to remember, But the safest thing to do is always create a save point if you're not quite sure. So generally in this slide here, once you start a start a query and you get a result, that's the end of the query unless you actually put in a commit, then it just locks it in. And I'll continue to say the implicit commit is always a part of developer. Data consistency, we started this out in understanding why the consistency of the data is important. There was a time where there would be slow reads and the table would be open for changes and there would be conflicts. It's not as big of a deal now. As a matter of fact, it's really not, because most of what happens within your database is instantaneous. And you can have several users hitting the same table at the same time, and the system is, I guess, structured enough that it will not, I mean, the timing on these things is ridiculously fast. So you usually don't have an issue with consistency, but this may be of concern if you're possibly in a legacy environment. And you're concerned about reads and updates and et cetera. So this is when consistency may be a concern. What I'm describing in these few slides is that ultimately your Oracle server is organizing all the instances of queries, especially DML. Updates, inserts are always, they have to be managed specifically. Usually have a database configuring some type of notification if there's a conflict. And there's ways of protecting that. You don't really need to know that completely. Just know that when you're running a query and you finish the query and you select the table and you know that everything was performed satisfactorily, you're done. You don't necessarily need to run a commit. If you need to change things, you can go right away and change things. And if you undo, you could actually change if you would like to use a save point and all that. But I would, and you're going to learn all about that when you run through the exercises. But and I just talked about this, the rollback and the save point is a way to protect it. But yeah, what happens is we call it dirty data. You may have a change and someone's expecting the change to occur, and it may be a point where the change is not visible yet. But in these high-end resource database systems, that's usually not the case. So most of these slides, if you want to review these, talks about creating save points, protecting the data, making sure there's consistency throughout the data, using this kind of transactional logic. And I will reiterate, it's not such a big deal. And these are just illustrations of where you put your save points and how you would roll back to make sure you have consistent data. It's just another way, if you're concerned about that, and you'll get a chance to kind of, if you want to, well, though we don't have multi-user environments in our instances, even if we did, it wouldn't really change things in this new level of Oracle developer. So, but Oracle would like you to learn about transactions and how they work and how you can protect your data consistency by continuing to run these particular processes. All right, automatic commit and data changes occur under the following. Yeah, so DDL, DCL, well, DML to a point too. I'm basically telling you that essentially, unless you're running, let's say you put in, because you don't want to run these queries one at a time, and you can do this in Oracle Developer. You put 20 queries in there. Well, if you want to be safe, you can throw in some save points in between those queries and then roll back to particular. But you don't with these systems, because it'll run those 20 queries not even without a hiccup, unless it's a very complex query. And even that, I haven't run into any problems. And that's the whole idea of implicit commit, implicit rollback, and all of that. So an automatic rollback occurs under any abnormal termination. So if for some reason you get a power failure there's an automatic rollback to where I don't know if you've noticed that. And within your Oracle developer, it had auto saves. If you really look at some of the indicators at the bottom, it's auto saving information, so you can always roll back. And basically the system now is high end as far as protection of data. So, and there's a data integrity initiative probably about 20, maybe 6 or 7 years, well, even before that, where it's not necessarily a concern as far as the consistency of the data because of the timing on the Oracle server. All right, locking. Not such a big deal anymore, as I said before, because of the timing, but it is important to prevent data from being changed by more than one user. And so there is a mechanism within Oracle so that you can lock and prevent destructive interactions. The way it works, it is performed automatically, and there's implicit and explicit. You can explicitly do a rollback if you like after a lock, but it's really hard to get into it to have a real-time instance with this because of the way we train you with these one user instances of the database. But yes, you do have the capabilities of locking a table, and those are the objects usually that you're locking to make sure the data integrity and data consistency remains. All right, so that was a rapid fire session on transaction. At this level, just be aware that understand what a commit is, understand what a save point is, understand what rollback means. The TCL language, we're not really going to get into that. If you're going to go into PL SQL, you get to learn all about TCL and how you can actually run what looks like a little program and have programs within programs or etc. So if you hear the terms TCL, know that stands for transaction control language, and you have DML and DDL and DCL. Now DCL is different than TCL. TCL transaction. DCL is basically the users and privileges and all that. So I know that's a lot to absorb. I apologize for that. All right. So what's left? We got through the final lecture. All right. What I'm going to do at the end of this lecture before I let you go this week, and I'll further reiterate that next week, you have the final project. I'm going to talk about that tonight a little bit. I'll further explain. I'll give you the highlight. It's really not anything overly complicated or sophisticated, but I will talk about it. And then the final exam. The final exam, just like any other final exam. I think I changed the opening of the exam to Monday morning. I think, yeah. So the exam will actually open before we even review it next week. And that being said, next week is basically a review of anything. I don't necessarily think I have a. Oh, let me look at the chat here before I go on. Mess me up. Oh, I guess that's an insider conversation. Yeah, if you have questions, please let me know. But anyway, so the final project, I'm going to talk about this once again briefly. So I'm going to stop sharing here in the PowerPoint. And well, I'm going to continue to share, but we're going to move away from the PowerPoint. Bring back my little image. Take a look. Oh, let me review. What we have this week, we went over privileges, regular expression. And remember, again, you're going to be asked to, and you'll have a lot of practice queries, but unfortunately, we don't have a way for you to practice these within the SQL developer, the way those instances are set up. All right, so we have, essentially this video is pretty good, speaking to what the things that I like, how do I call this? I just very quickly went over on commit and rollback and save point, how that works. So review that, and then we have all the practices. Once again, this is mostly just review of information. I'm gonna kind of skip through these. There's four sections of these. So let me quickly go through these at this level. Yes, we're in module 14, so there's 4. And then we have the assignment, and yes, remember, the assignment, let me make sure. I think I basically put, yeah. So the queries do not need to be run, but you need to create the queries for each of these. And you don't have to run them. I just want to see the queries when you submit that. So this is the first time that you can do these without actually running the queries. Okay. Pretty simple. All right. And then we have the quiz. And yes, I would definitely reference the lecture material in the 4 sections before you take the quiz, because that will cover all the questions in there. Okay. All right. So you just have the assignment and the quiz, and then we'll be into module 15 or the last week. And so we will have a lecture. Well, not really a lecture, kind of a review. I'll talk more about the project. You can get started on it anytime. But let me open this up and show you what I mean. So I do have a video to give you the project overview, and please watch this. I just created this, basically last semester, a year ago. This will tell you exactly what I'm looking for. And high level, I'm going to ask you to create this movie renting database. Yes, this is kind of old school. It's like Blockbuster used to be, but when it online. So it's kind of, I'm thinking about changing the project, but this comes right out of Oracle. So basically what you have the requirements. So you want to make sure, and you do even have a list of queries here. Drop any of these tables and you create this table customers. You create a movie table. You create a media table. And then you create sequences. And then you insert movies, insert into media, insert to rental history. So you're basically creating these tables, and then you're running a scenario. The last part of it, after you create all the objects, you're running a scenario where you're renting a movie, and you're simulating what happens when you rent a movie. And you think about it, basically you're inserting the movie. Well, and I'll talk about that. But it's pretty simple. The way that I want you to run it, as you create your data, you're actually creating the instance of you renting this movie, like Star Wars or whatever. So the good thing about it, you have all the aspects, the criteria, and then I provide all the aspects, even most of the queries, and some of the example data. I do want you to add yourself to the customer database, because you're going to essentially tell me after you build this little, and yes, you build it right on your schema. You're not creating a new schema, you're just creating the new tables. Does everyone understand that? You're creating new tables in your schema, not because we don't have the ability to have you create another schema. So all of the queries that you need, of course, you have to be careful running these. I will warn you all that copy and paste, there may be some issues with these, and they're easy to recognize. That's another part of the challenge here. But for the most part, it's straightforward. It's just essentially capturing all the queries, creating a scenario. And once again, the last part of this, I will remind you next week, the last part is just walking through a scenario. What happens if you're renting a movie. So, and you can just walk through it. You can either walk through it using SQL Developer or just walk through it using a narrative. I'm okay with that. That's the project. Does anyone have any questions about that? No. No questions? Everyone's so quiet today. All right, so that's the project, and that's due the last day of class, Friday the 19th. And basically, screenshots of all, and you can take a screenshot of I don't need, well, all right, I don't need you to screenshot every one of the queries, but I need you to screenshot the tables that you've created successful. So when you expand in SQL Developer, and you will need to show me that you have SQL Developer running, but, and yes, you can show me the queries that they've run successfully, but I'd like for you to expand your RCL, expand your table view, and basically give me a screenshot of those tables in the connections. You should have the tables in there. I don't have them in this schema. I eliminated. Does that make sense to everyone? So I expect the tables to show there, or you can click on the table and show the table properties, etc. So that's what I'm looking for once you finish the project. And then the scenario could just be a document that you submit along with that. And yes, that is and I do have the requirements here in the online media rentals outline, with all of the information's in here. I have additional information. Don't let this confuse you. The criteria for the project is in the information that I provided for you. And this is just 40 points, so don't panic. I mean, it's all pretty straightforward. But I do want you to create a narrative where you're renting a movie. You can even just say, when I rent a movie, this happens, my address, blah, blah, blah. I know it's not blah, 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 but yeah, that is a part of the kind of it's not really in the rubrics, but that's one of my requirements. All right, then briefly, and I'll talk about this, I'll flesh this out a little bit more. Next week, our last meeting, our meeting next week will not be long. There's a study guide for the final. Please print it out, because you won't be able to open it after you get into the final, because of it is respondents lockdown. We're going through modules 9 through 14. Everything in bold is what's to focus on. As you see, some of the things, especially in module 14, we're not even covering. Mostly objects, constraints. But please read through this list. Please add your own notes to make sure you know all of these things, and then you'll be ready for the final. And then once again, the final will open Monday the 15th. Oh, that's just 12 a.m. Anyway, it's going to be open Monday. And then it closes Friday at midnight. So basically, it opens early. It'll be open when you get to class next week. All right. There's 50 questions. It's 100. It is 100 points, so 2 points a question, and it's a 2-hour limit. So you have plenty of time. And it's very, very similar to the midterm. Okie doke. All right, let me stop sharing. And okay, we only have one more evening where we'll meet. Finish module 14. Once again, is review the lecture slides when I post them before you do the quiz, and all of the queries in the assignment are just, you do not have to show me in SQL Developer, but you will need to know some of that information when you take the quiz, and some of that will be on the final. Not much of it, but some of it. Okay, any questions, comments, concerns? We're almost done. You're all sad now, right? No, everyone's like, boo, hallelujah. All right, then. Thank you all for your attention. I know this was pretty dry and very boring. Probably watching the football game. But anyway, thank you all. And I'll see you for our last night next week. And you'll be done. You're all going to pass, right?
Thank you. See you next week.
See you next week.